Hello viewers, welcome back to our YouTube channel, and today we want to continue with our series of quantitative techniques. And what we want to look at, the mean deviation, because in the previous video we had spoke about the quartile deviation. So this will be the last item that we are going to talk about as far as chapter 7 is concerned for the measures of dispersion. So what we are interested in handling today is the mean deviation. Of course, as I said, mean deviation is one of the measures of dispersion that gives us the average absolute difference between each value or each item and the mean. In other words, if you are looking for the definition, the mean deviation, this is the measure of dispersion, that gives the average absolute difference, between each item and the mean. So that's the definition for the mean deviation. Of course, it looks at each individual item and it gives us the difference between each item and the mean. In other words, you get the individual value that has been given to you, the x value, minus the mean. But here we take the absolute difference. So the absolute difference means we ignore the sign, whether it's a negative or it's a positive. We just take out the difference. If it is a negative, we just take out the figure. If it is maybe negative 20, we just take out the 20. That's the absolute difference that we are talking about. So for it should be noted that the mean difference, of course, it is much more representative. It's a much more representative measure as compared to the range, because for the mean deviation, it uses all the item or all the values of the distribution. In other words, when you are computing the mean deviation, we consider all the items or values that are within the distribution when you are carrying out the computations. So the mean deviation is obtained, of course, using different formulas depending on whether you are dealing with ungrouped data set or the grouped data set. So I don't want us to make this much more theoretical as it should be, because it's supposed to be a computational thing. But I want us to have this note, NB. This is very important. I've talked about it, but I want to focus on it, that the absolute the absolute difference that we are talking about, that is of course x value minus the mean. Mean is x bar. We are going to take, maybe we are going to use x bar. That absolute, but you remember the absolute, they are not bracket, they are always those parallel lines. Of course, though, that's the absolute difference. It means that absolute difference means just the magnitude, or what you call the size of the difference, the size of the difference, and it ignores the negative sign. It ignores the negative sign. So even if we get the absolute, those absolute signs help us to remove the negative item. So I want us to look at the formula that we can use so that we can be able to get the mean deviation. Other people call it mean deviation, others call it mean absolute difference. So whichever the case, we said it ignores the negative sign. It ignores the negative sign. So if we are dealing with ungrouped data, the formula that we use for the mean deviation is actually the formula that we use summation, is summation x minus the mean over n. Others may use for the mean x bar, they may use letter m to represent the mean, where x bar is the mean or the average, and our n is the number of observations, Of course, the x minus the mean now will be representing the absolute difference. So that's the formula for, especially if you are dealing with a data set that is ungrouped. I want us now to look at the data set that is grouped. Once we have seen that, then we can be able to move ahead and we'll look at the different computations. We get the grouped data set. For grouped data set, the mean deviation is given by, now we just put in the frequency. It will be summation f into is x minus x bar. This shows we are taking the absolute divided by summation f. So where the summation f is the total frequency, where summation f is the total frequency, meaning the f represents the frequency, total frequency. So we take the absolute values, even for the ungrouped data, we also take the same. They are supposed to be, sometimes they may write the formula as 1 over n into, now the summation, now this will be the absolute of x minus x bar. So the ungrouped here, they are supposed to be absolute values, these ones, absolute value. In other words, we ignore the negative signs. So I want us to look at a simulation. Let's get maybe a small number. We do some small computation. Let's look at an example. We first look for the ungrouped data. Just maybe take a small number. Maybe you can say find the mean deviation. Find the mean deviation of the set of numbers. The numbers we have 45, 54, 64, 76, then 86. Just 5 numbers. So let's get the absolute value. Solution. So the first thing we first get the mean. So we first get the mean. And our mean is the x bar. Of course, mean, we know that it is, for us to get the mean, it is summation x over n. So we just sum up these values. It will be 45 plus 54 plus 64 plus 76 plus 86, and all of this, they are how many? They are 5 numbers, so you divide by 5, and this will give you 325 divided by 5, that gives you 65. That is your mean. Now we go to the mean deviation, because we need the absolute values. So we get the mean deviation. But this same information can be arranged in a table. If you want, you can organize this information in the table. So we say the mean deviation is going to be summation of the absolute of x minus x bar. We have gotten our x bar divided by n. So I'm just going to subtract this information. So this will be, I'm looking for the absolute. The first number was 45 minus 65 plus the absolute of 54, that was the second number, minus 65. 65 is our mean, plus the absolute of 64 minus 65, then plus the absolute of 76 minus 65, plus the absolute of 86, that's the last number, minus 65. The whole of this divided by, what is the number? These numbers, they are 5. And this will give you, of course, the final answer will be a 12.8. That is our mean deviation. Mean deviation of 12.8. Now, if we had maybe frequency for the grouped, maybe we can have a small question just to show ourselves how we can navigate through when it's of course you can see that the one for grouped data set, what is going to be added there will be just the frequency. And the second thing is that we shall not have the x values, meaning we shall be using the midpoints. But one thing I want to explain, I think we are going to do, we are going to do this number for the grouped data set. The good thing that we have the idea, I want us to first look at variance. Then we shall pick one question, and then we do variance, standard deviation, and then the mean deviation for the grouped data set, so that we get a whole complete idea. I think that will save much more time. Now, first of all, I want to talk about the variance. And the variance I want to talk about is going to be grouped into the variance of a sample and then the variance of a population. Now I want us to look at the variance. Then we shall do one question that will combine all these items. The variance of a population. Let me start with the variance of a population. And I want you to get it clearly. If we are looking at variance of the population, of course, the formula is going to be the same like that of the mean deviation, but what is going to change is that these observations are going to be squared. In other words, if you are looking at variance of a population, the formula will be summation of, now even if we don't put the absolute, because these values are going to be squared anyway, so x minus x bar bracket squared over n, where x bar is the mean, is equal to mean. I think this one I should just use capital N, because small n is always for the sample. Let me use capital. This is the mean, and then the other n is going to be representing the number of observations. Number of observations. This is for ungrouped data set. Ungrouped data. If the data is ungrouped, we use that. Sometimes you'll find some textbooks adding values here that from I to N. Those ones are just there to confuse you. Those ones, even if you don't indicate them there, but they're just implying. Of course, if they put I there, then it means even here there is an I. But those are known to that even if you state it the other way, it will be right. Now, we are going to use the same question that we used up there to get the same question that we have just used it to compute the mean deviation. Because it is the same formula, what is only changing is that we are squaring the values. We are squaring the absolute values. So that's one of the formula. I'm also going to give you another formula. But all these formulas, once you use them, you are going to get the same answers. But if you take this one gives you so much work. Now the other formula is to use, if you don't use that, you can use this, or variance is equal to summation, it is summation x squared over n minus summation x over n bracket squared. So these two formulas, once you use them, the summation x squared over n minus summation x over n, the whole of it, bracket squared. So this is mean squared. It's like having mean squared. Any of those two, as long as you are dealing with a population, those two formulas give you the same answer. So I want you to use the same question to do. Now I'm going to use this second formula, but for you use the other first one, whereby you just get where we go to the other differences, you just square the differences. This is what you are going to do. It is the same question. These are x values. This is x. We had 45, 54, 64, 76, and then 86. You put it in a table. Now here we are going to get x squared. X squared. This is summation x equals, then summation x squared equals. Now we start computing. The 45 squared is giving us 2025. The 54 squared, it gives you 2916. Then 64 squared gives you 4096. Then 76 squared gives you 57, 76. And finally 86 squared gives you 7, 73, 96. Now you add all these. When you add, you'll get 22209. When you add here the total x values, they were 325. Now we substitute in the formula. We said we are going to use, the formula that we are going to use is summation x squared over n minus summation x over n bracket squared. So we substitute. So this is 22209 divided by n, there are 5 values, divided by 5 minus 325 over 5, but the whole of it, we square that. We will get 216.8. Even if you use the other first formula, you will still get the same answer. That is, if at all you are using, and I know this is the very common method everyone knows, but you have to be very careful when the examiner tells you that the data set they have given to you is for a sample, and now they are telling you to get the variance of a sample. That's different. Now, I want us to have the other formula for computing variance, but for grouped data set. We have it at once as well. When we are computing variance of a population, but this time round for grouped data set. Of course, that one all of us are familiar with that. So one thing that I want us to focus so much is when they have asked us to get the variance of a sample. For this one, at least, if you have, maybe if you did some mathematics, you probably you know. So if you are looking for the grouped data set, for the grouped data set, then the variance will be given by summation fx squared over summation f minus summation fx over summation f, whole of it squared. So this is what we used to do. What they have just put, it is the same like the one above. What they have introduced here is just the frequency, that f. Instead of using the n as the number of observation, they have used the total frequency. So that is for grouped data set. If at all there is some kind of assumed mean, if they have provided for you maybe the assumed mean, if you have assumed mean, then variance will be, it will change, it will just be summation fd squared over summation f minus summation fd over summation f bracket squared. We computed some of these things, summation f that's why I'm not repeating some of these. If at all you have some something to do with assumed mean. But most of the times they prefer that one, and that first one, the one that deals with this, the one that is most preferred, or that's depending on the data set that they have given to you. So those are some of the methods that we look at, and most of the times in the examination you will be finding variance, but they want it for the population. Now I'm just giving the one for a sample in those rare cases. I'm not saying this can't be examined. It can as well be examined because it's part of what you're supposed to know. But as I told you, basing on what they have been examining, they have not been examining the ones for a sample. So for you to use these methods that I'm going to give you, the examiner has to specify that the data set they have given to you is for a sample, whether grouped or ungrouped. So you have to be very careful, because for the sample we know that the symbol for variance is s squared. If at all you're looking for the variance of the sample. Now, of course, I've not talked about the standard deviation. If they ask for the standard deviation, if the examiner asks for the standard deviation, it is just the square root of variance. In other words, what you have computed as the variance, you just take the square root. So if the examiner asks you for the variance, there is none, even if he doesn't mention that compute variance, it means you have to compute variance, because there is no standard formula for computing standard deviation. But one key thing you need to understand is that you have to know whether the examiner is not talking about the maybe standard deviation of a sample. If the examiner remains silent, we assume that we are dealing with the population and we take this formula. It is only in those rare cases where the examiner will ask for you to compute the variance of the sample, and he has to specify that it is the data set that has been given to you is for a sample. So he can go ahead to ask you to compute the sample standard deviation, sample variance, and so on. For the mean, whether it is sample or population, the formula remains the same, but it is only the variance that changes depending on what the examiner is trying to ask you to compute. So we have said that if they ask you for the standard deviation, you just get the square root of variance. You don't have a standard formula for computing standard deviation. So the moment you get your variance, you just get the square root of it, and that will give you the standard deviation. If the examiner gives you the variance and wants you to get he has given to you the variance, he has given to you the standard deviation and wants the variance, you just square the standard deviation to give you get standard deviation squared for you to get the variance. So the reason as to why the examiner may give you, this is specifically for when you are looking for the variance of the sample. Let me write it in capital letters. Now, the variance of a sample, the only reason as to why the examiner can ask you that is because most of the times we always analyze the sample. We sample items, then we analyze, and then we estimate what we call a parameter. A parameter is just a numerical value representing the population. So we always look at a statistic, and it's the one that we use to estimate the parameter. In other words, we look at samples to estimate, we analyze them, we study them, then we make a generalization, or we make conclusions about the entire population parameter. We can look at a small number of people, then we get maybe their mean, and then we assume that because we can say in the entire university maybe we have picked like 20 people from each of the faculties. Then we say we get their age, we get the average age of those students that we have picked, and then we make a generalization that in the entire university most of the average age is this, when we have not studied the entire population. So you need to know the advantages of studying a sample rather than a population, because it is very easy for you to study a sample. You pick out very few people, then you make a conclusion about the entire population. It will be very easy for you, very cheap, and also so that's why I was telling you that when you are dealing with the population, you use capital N for the number of observation. Then when we are dealing with a sample, we use the small n. Now, the same thing will happen if they are asking you the sample standard deviation. It will be the positive square root of the sample variance. Because it is one of the most sophisticated measures of, it's the one that is most useful and one of the most sophisticated measure of variation, because it helps you to describe the scatter of the scores around the mean. So it is a very stable measure. So when you are looking at the standard deviation, is one of the best. It gives good measures of variability than the range or the quartile deviation. Now we want us to look at the formula for variance. If we are dealing with ungrouped data, if you are dealing with ungrouped data, then variance will be equaling to, it will be summation x minus x bar of course the whole of it is squared, but we divide this by n minus 1. We divide it by n minus 1. So we get x minus x bar divided by n minus 1. We use n minus 1 instead of n. If you don't use that, there is also another formula, and both of them, they give the same answer. It depends on what you want to use. If you don't use that, you can use this one, or you can use n over n minus 1 then the whole of it, you are multiplying the whole of it, summation x squared over n minus summation x over n bracket squared. This will also give you the same answer. Because I told you for standard deviation, for variance, we use s squared. Now, if you are getting the standard deviation, of course, now the standard deviation of a sample will be the square root. Now we put everything, maybe summation x minus x bar bracket squared over n minus 1, the whole of that under the square root. So that is the standard deviation, or you can call it sigma. I'm not using complicated letters because I know you are not a mathematician, but you, even if you just write the whole word, it will be fine. So if we are dealing with ungrouped data set, those are the formulas that we expect you to know. Use the same data that we used up there to compute. We have already computed x squared. We have these other ones. So you just plug in, you will see that it will give you the same answer. We can maybe just try it because we have already gotten those values up there. We have already put in those values. You can just put maybe an example just for you to see. We have gotten those summation x squared. We got that as 3.209, and we also got summation x as 325. So we just substitute into the formula. We said sample standard deviation, or s squared, is equal to, we said it is summation. Let me start with this big one, n over n minus 1, n over n minus 1, the whole of this summation x squared over n minus summation x over n bracket squared, the whole of this. So this is giving us, we know that our n is 5. N is 5, so it will be 5 over 5 minus 1, the whole of this, into 3.209 divided by 5 minus 325 over 5 bracket squared. So we substitute, we put in the calculator. Let's start with what is inside. Of course, this is 5 over 4, 5 over 4 into, this first one is 3.4, 1.8 minus, what is our mean squared? 325 divided by 5, that gives you 65. 65 squared is 4 4,225. 4,225. So once you, of course, you less off, inside there you get 216.8. Now this one times 5, then divide by 4. That gives you 271. It gives you 271. Now I want us to put the other formula. We see whether we are getting the same answers. But just know we are going to be getting the same answers. You try out that second one, because we didn't compute the summation, the summation x minus x bar squared. We didn't compute that. So you try to compute that one, and then you see whether you will get the same answer. But the answers are supposed to be the same. Now I want us to look at, if at all they had given us grouped data, but they want us to use to find the variance of a sample with the grouped data. Of course, it will be the same formula. Where you are seeing n, we shall put summation f. And where you are seeing summation x squared, we shall put summation f x squared and summation f. And that's it. So I want you to have all these formulas so that you can know which one is easier for you to remember. So I want us to look at the grouped data set, and we are looking at sample variance, or what we call S squared. S squared for the grouped data set, the first formula you can use is, of course, summation f into x minus x bar bracket squared over summation f minus 1. Or you can use this S squared is equal to summation f over summation f minus 1 then you put summation f x squared over summation f minus summation fx over summation f bracket squared any of these will give you same answers. So you can try out those with, of course, we are going to look at a number that has grouped frequencies so that we can be able to internalize. The moment they ask for you for the standard deviation, you just get the square root of variance and you will be good to go. So that's basically what I wanted to look at as far as the formulas are concerned. Now, one thing that the examiner always adds as they are looking at the measures of as they are looking at the measures of variation, they always add what we call the coefficient of variation. One thing that you need also to recognize is the fact that the examiner can tell you to interpret your values. Just when they give you the variance measures the spread of the distribution about the mean. Standard deviation, of course, we understand that a larger standard deviation indicates that the data points are far away from the mean, and a smaller standard deviation indicates that they are clustered closely around the mean. So if you get a higher standard deviation, the implication is that those values are so much scattered away from the middle value. So you look at your mean, and then you look at these other values. Of course, there are some properties for standard deviation and then the coefficient of variation. Those two, they are the ones, if they don't tell you to explain the coefficient of variation, they can tell you to explain the standard deviation. But both, if the examiner tells you to compute the coefficient of variation, automatically you need to compute the standard deviation, because within the coefficient of variation, we use standard deviation over mean times 100. So the standard deviation is only used to measure spread or the dispersion around the mean of the data set. The other aspect as a property is that the standard deviation can never be negative. And even the other aspect is that the standard deviation is more sensitive to outliers, because a single outlier can raise the standard deviation, and in turn it distorts the picture of how spread the data set is if you are comparing it with the mean. So the coefficient, maybe we also put the coefficient of variation, then we go ahead to explain everything in one number. We pick one number, we do all. So the coefficient of variation, and we have said that for the coefficient of variation, it measures the spread as well. Of course, we never want to compare the variation between two series of, let's say, of the same mean, which are maybe measured in different units. We don't just compute the measures of dispersion, but we are required to measure to have such measures, and we get whether they are independent of these units. So for the coefficient of variation, in terms of the formula, they can call it CV. It is equivalent to standard deviation over mean. Standard deviation over mean times 100. It's a percentage. So if we are interpreting it, you have to understand that the greater the coefficient of variation, then the more the values are going to be more spread. But if it is small, then they are going to be consistent with the mean. So some of these things we are going to understand them when we pick a practical question, so that we try and go through some of these other items. You pick a question and make sure you go through the different computations using the formula, because what you need is a formula, and then you do the computation. We have been doing these computations. You know how to compute the mean, you know how to compute the midpoint. So let's just pick maybe one question, and then maybe we compute, we pick one and we compute maybe the example, but here we are looking at group T data. The annual salary structure. The annual salary structure for workers in a certain NGO follows the distribution below. So we have the salary. This salary is in millions. Then we have the number of employees. From 10, remember they are in millions, 10 to 14, 15 to 19, 20 to 24, 25 to 29, 30, 34, and finally 35 to 39. So the frequency, this one is 1, this is 14, this is 23, this is 21, this is 15, this is 6. So the required, we are going to calculate the coefficient of variation, because when they ask you for the coefficient of variation, it means you are going to compute the mean, you are going to compute the standard deviation, you are going to compute the variance, and then finally you compute the coefficient of variation, because you can't compute the coefficient of variation minus computing all those items. Even if the examiner tells you just compute standard deviation, you'll find yourself you have to compute even the mean. So we get the solution. Now you have to understand what is the required. The required is for us to compute the coefficient of variation. Of course, we said we need mean, we need variance, we need standard deviation. Those are the ones we need. It means we don't need the class boundaries. So don't find yourself making class boundaries, because they are not necessary. Otherwise, class boundaries are going to also be made if they are talking about maybe median or mode. So here we start with the salary. Oh, those are the classes. It is 10, to 14, 15 to 19, then 20 to 24, 25 to 29, 30 to 34, and then 35 to 39. Of course, you can. Now, what we need is the x value, that's the midpoint. We said you first get the class interval. The class interval is 5. So you get 10 plus 14, you divide by 2. You get the midpoint. That is 12. Now, 12 that we have got is for this class, the midpoint. Now, 12 plus 5, it will give you 17. Even if you get 15 plus 19 divided by 2, that will give you 17. So either way, you adapt to whichever way that will save you time. This is 17 plus 5. If you add 5 there, you'll be getting 22. As long as the class interval they are the same, you just move like that. 27 here, plus 5, 32, plus 5, 37. That's done. Then we get f. This f was given to us as 1, 14. This one we don't compute. They gave it to us. 21, 16, and 6. Now we add here. We get the summation f. Because we need to use, we are going to use it. So summation f is 81. Our total frequency is 81. Now we go to fx. Fx, we get frequency times the midpoint. 12 times 1, that's 12. 17 times 14, that is 238. Then 22 times 23, that is 506. Then 27 times 21, that is 567. 567. Then 32 times 16, that is 512. Then 37 times 6, that is 222. 342. Now we also need this summation fx. The total here for summation fx is 2057. You add all those values, 2057. Then we get our x squared. X squared. We square the x. We get our x squared. 12 squared, that is 144. Then 17 squared, that is 289. 289. Then 22 squared, it gives you 484. Then 27 squared, it gives you 729. 729. Then 32 squared, it will give you 1024. Then finally 37 squared, giving you 1369. we don't need this x squared, we don't need the total, but what we need is the fx squared. So we get 1 times 144, it will be 144. Then we get 14 times 289, that gives us 46. Then 23 times 484, that gives us 11132. Then 21 times 729, that gives me 15309. Then 16 times 1024, it will give me 16384. Then finally 6 times 1369, it will give me 8214. But I need the total here, summation fx squared. I need the total. If I add up all those, they will give me 55,229. For you, if you want to use the other methods, you can now get x minus x bar if you want. Then you get x. You can also get, of course you get this one squared, but I can get f into x minus x bar bracket squared. So if you want, you also get those totals for the other methods. But for me, I'm not going to go into that part, because this information that I have is enough for me to get the other values that they're asking me to do. Whatever I've got is enough for me to compute the correlation, the coefficient of variation. So let me now start by looking at, of course you have seen in that question they have not told you that it's a sample. Most of the times if it is a grouped data set, we always assume that we have been given what? We have been given population. So it is very important for you to understand, even you get the advantages because they can throw 1 mark. If you can also try, if they have been maybe given to you, you use even the assumed mean, so that you can expedite all the formulas that we have talked about. You create one table, then you put all these other formulas so that you compute them at once and you compare the results, bearing in mind the information for those formulas that are related to a sample. You compute them separated, then these ones for population, and you verify what we've talked about, whether they will give you the same answers. So you make sure the answers you get, you post them on the comment section. Then I will comment to tell you whether they are right or they are wrong. So let's finalize. with what we were asked. They asked us to get the correlation, the coefficient of variation, which is the standard deviation over mean times 100. It's a percentage, but you can even leave it as a ratio. It's okay. So we want to first start by getting the standard deviation. We know standard deviation is the square root of variance. So what we are going to first get, let's first get the variance now. Variance is summation fx squared over summation f minus summation fx over summation f bracket squared. So we substitute in the values. So let's substitute in the values and then we finalize this. So summation fx squared is 55,229 divided by summation f is 81 minus 2057 divided by 81 bracket squared. Once you substitute that in the calculator, it will give you 36.9299. Let me just stop there. 99 as your standard deviation. As that's the variance. Now for the standard deviation, is equal to the square root of variance, meaning it will be the square root of 36.929929. More than that, then you get the square root. It's around 6.07. You can make maybe 3 decimal places, 77 to 3 decimal place. Now we have gotten that one. The next thing that we want us to get is the mean. Of course, the mean is from this point. We get the mean. The mean is summation fx over summation f, which is 2057 divided by 81. 2057 divided by 81, that gives you 25.39. This gives you 25.3951. Then you get this standard deviation over mean times 100, and you are done. So we compute the coefficient of variation, and we said it is standard deviation, and our standard deviation is 6.077 over 25.3951 times 100, and this will give you 23.93%. That's it. That's basically what they wanted us to compute. But for you, go ahead and compute using all the methods for both population and then the mean, so that you can find out whether you are getting the same answers, and they must be. Compute, you can pick any assumed mean, whether it is inside or outside, and you compute, whether it is inside the distribution or it is outside the distribution. So that's all that we wanted to talk about as far as the measures of central tendencies are concerned. And the rest of the items that we have not talked about, that all that we have not computed, we are going to have revision lectures where we shall use those past papers and we try to internalize, because my goal is to look at the past papers and then we do number by number. Don't forget to also look at the percentiles, the deciles, and then you get numbers and you compute. So that's all for chapter 7. The chapter that we are going to look at will be chapter 8, that deals with measures of skewness, where we shall look at the relationship between mean, mode, and median. And then we try to look at using those items. They will be giving us a direction of whether the distribution is skewed to the right or to the left, or it's a normal distribution. So those are the things that we are going to cover as far as measure of central tendency is concerned. Then of course we shall also put in some kurtosis that represents the measure of pickedness of the distribution, how the data set is going to be picked, whether it is having a sharp peak at the bottom, at the middle of the distribution. And once we are done with that, then of course we shall slide into the probability, and then we do things to do with hypothesis, things to do with estimation, things to do with the confidential interval, and so on. So as far as the paper is concerned, at least we have covered, I can confirm that we have covered at least 40%, 40 to 50% of the paper, depending on how they have been examining these numbers. If you look at the past paper number, you can still do as many numbers as possible basing on what we have so far discussed for those 7 chapters. So by the time we conclude the 8th chapter, because it's the one that will give us the opening platform for the normal distribution, where we shall talk about the Z tables, the Z scores. It is this measure of skewness that will give us that small bit into what we shall discuss from the normal distributions and so forth. So for those that want to join our recorded lectures, and these recorded lectures are free from ads, so your ads are not going to disrupt your content. You're going to make content, and you're going to watch the content without stoppage, meaning your data is not going to be consumed at only 200,000 Ugandan shillings. You'll access these classes. We have both classes and revision classes for different past paper numbers of different sittings in different syllabuses. So you will join and access these the moment you reach out on our WhatsApp number. We will give you the direction on how you can make the payment to our company account, and then we grant you access for a full year package from the time of payment.